Here we are at example 4f from our 1.3 number 2 set of notes. Now we're seeing that we have the limit as x approaches 0 of the sine squared of 2x over x squared, and if you try direct evaluation you would get that 0 over 0 in determinate form, so we're going to have to maybe try something else. Now again, dealing with limits, we know that we have the product property of limits, and that just pretty much says that we can go ahead and break things up into multiplication. And if they are in fact equivalent in like algebra, then they should in fact be equivalent in terms of limits. So what we can go ahead and do then is break up this limit where we have, see how we have sine squared of 2x? Well, I'm just going to go ahead, and again, if you think back, really what that means is just sine of 2x quantity squared. So really there are two sine of 2x's. I'm going to just go ahead and break that up where we have a sine of 2x as one of them, and then another one, a sine of 2x. On the bottoms, we have x squared. Well, again, kind of that same idea where we can go ahead and break that up. So I'm going to have 1x over here times another x over here. Now, this is incredibly close to what we've seen in the past. There's just one thing. These numbers are not matching. But what we can do is just a little bit of foo to get them to match. So if we in fact want this number to match on the bottom, what we're going to do is multiply it by 2 on the bottom. But in order to keep this to be an equivalent statement, we're going to have to go ahead and multiply 2 on the top. The same exact scenarios are happening right here. So we're just going to do a little bit of foo by multiplying 2 over 2. And when we do that, we end up with the limit as x approaches 0 of 2 times the sine of 2x all over 2 times x times 2 sine of 2x all over 2 times x. So at this point, I'm going to go ahead and break these limits up just so it's a little bit easier for us to see. So again, we can go ahead and apply this limit to both of these items using that product property with limits. So we have the limit as x approaches 0 of 2 sine of 2x all over 2x times the limit as x approaches 0 of 2 sine of 2x all over 2x. Now at this point, these guys match the sine of 2x over 2x, but we still have this 2 out in front. Well, if you think about it, really that 2 just happens to be a constant that we can go ahead and move in front of our limit. Likewise, this 2 can move in front of our limit, because again, that's just some constant. So we end up then with 2 times the limit as x approaches 0 of the sine of 2x all over 2x times 2 times the limit as x approaches 0 of the sine of 2x all over 2x. And just from before, we know that this entire limit, now that they do in fact match, just comes out to be 1. So ultimately we really just have 2 times 1 times 2. And again, this limit is exactly the same, so that's just 1. So ultimately, it looks like our limit just comes out to be 4. So again, that is example 4f from our 1.3 number 2 set of notes.